Okay, good morning, class. Yesterday we ended with recording for tomorrow. Yesterday we ended with the combination of functions. We added functions, we multiplied functions, we subtracted, and we divided. Today we're going to take a look at the composition of functions. So again, the composition of functions. So let's take a look at what we ended with yesterday. So let's say we have f of x is equal to x minus 5, and g of x is equal to x squared minus 1. So f plus g of x is f of x plus g of x. And that gives us x minus 5 plus x squared minus 1. And combining like terms and everything, we end up with x squared and then plus x. And here we have a negative 5 plus a negative 1, so that's minus 6. F minus g of x is f of x minus g of x. So for that one, we have x minus 5 minus x squared minus 1. And what we always have to remember here is we do have to distribute our negative sign. So that leaves us with x minus 5 minus x squared, then minus a negative 1 plus 1. And rewriting that, we're going to end up with negative x squared plus x, and then negative 5 plus 1 is minus 4. And then I believe we said that f minus g and g minus f are not the same. So let's take a look at that. G minus f of x is g of x minus f of x. So that's x squared minus 1 minus x minus 5, distributing x squared minus 1 minus x minus a negative 5 plus 5. And that's equal to x squared minus x. Negative 1 plus 5 is a plus 4. So f minus g and g minus f are not the same. Okay, next we have f divided by g of x, which is f of x divided by g of x. So that's going to give us x minus 5 over x squared minus 1. And similarly, g over f of x would give you g of x divided by f of x. Well, today we're going to take a look at the composition of functions. And you've been doing compositions of functions probably since elementary school. If I told you that f of x is equal to x plus 3 and g of x is equal to, and I asked you for the following. If I asked you for f of 2, I think all of you are super comfortable with saying, well, in f, where I have an x, I'm going to replace it with 2, so I get 2 plus 3. And our answer is going to be 5. Well, what if instead I asked you to evaluate f of g of x? Well, it is the exact same concept as just substituting in the 2. In your function f, everywhere you have an x, you're going to replace it with g of x. So f of g of x would be g of x plus 3. And then we have already defined that g of x is equal to, so that's 2 plus 3, and that's equal to 5. So what we have to get comfortable with is inputting values that are not numerical, not constant. Okay, so in this same problem, if I were to ask you what f of happy face is, then that's just going to be, well, f of x is equal to x plus 3. Everywhere you have an x, you're going to replace it with a happy face. So our final answer would be happy face plus 3. They are not like terms, so that would be our final answer. So that's the comfortability that we have to get to. Okay, so the composition of the function f with g is denoted f of g. And if that's a function of x, then that's the same thing as f of g of x. G of x is your inside function, f is your outside function. Now, what about domain? Because we covered domain a lot yesterday. So the domain of f of g of x, again, where g is our inside function. So the domain of the composition of these functions is the set of all x such that, number 1, x has to be in the domain of g, and number 2, g of x is in the domain of f. All right. So let's take a look at a couple of examples. So let's say that f of x is equal to 3x minus 4. And g of x is equal to x squared minus 2x plus 6. Then what is f of g of x? In other words, f of g of x. Well, what we're going to do is we're going to take a look at the function f. And everywhere you have an x, you replace it with g of x. So that's going to be 3 times g of x. And then minus 4. So everywhere we had an x, we replaced that x with g of x. Here and here. So that's equal 3. Well, but g of x is x squared minus 2x plus 6. So it's 3 times x squared minus 2x plus 6. And then minus 4. So now we're going to distribute our 3. So that's 3x squared. 3 times negative 2x is negative 6x. 3 times 6 is plus 18. And then we still have this minus 4. So combining like terms, we get f of g of x is equal 3x squared minus 6x, and 18 minus 4 is plus 14. And that's our final solution. Okay. Now, how about g of f of x? So now your inside function is f, your outside function is g. G is squared minus 2 times x plus 6. So everywhere you have an x in g, you're going to replace it with f of x. So that becomes, because this is x squared, it's going to become f of x squared minus 2 times x, so minus 2 times f of x, and then plus 6. Substituting in those values, we end up with 3x minus 4, and we're going to square that because that's our x squared, then minus 2 times 3x minus 4, so that's our 2 times x, and then plus 6. So this is x squared minus 2x plus 6, f of x squared minus 2 times f of x plus 6. Okay, now we have to expand this. So 3x minus 4 times 3x minus 4. 3x minus 4. 3x minus 4. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. 3x times negative 4 is negative 12x. And negative 4 times negative 4 is a positive 16. So this becomes 9x squared. Negative 12x minus 12x is minus 24x. And then plus 16. And we still have to do this part. So negative 2 times 3x is minus 6x. Negative 2 times the negative 4 is plus 8. And now we have the plus 6. So let's combine our like terms. So our like terms are, we have a negative 24x and a negative 6x. We have a constant of 16, of 8, and of 6. So our final answer is 9x squared. Negative 24x minus 6x is negative 30x. And then 16 plus 8 is 24, and 24 plus 6 is 30. And that's our final solution. So it seems as though when we did the composition of g of f of x, that was a little more difficult than the composition of f of g of x. So the final thing we want to do, if we wanted to find g of f of 1, well, we've already found g of f of x. So now all we have to do is substitute a 1 in here, and that'll be 9 times 1 squared minus 30 times 1, and then plus 30. So 9 times 1 squared is 9. 9 minus 30 is negative 21. And negative 30 plus 30 is 0, and then you have a 9. So our answer there is 9. Okay, so that's it as far as the lesson. And your homework will be lesson 1.7, page 258. Numbers 51 through 65 odd. And I will see you next week.